And our last speaker in this slot before the break is Michal Feldman, who is already prepared from the MHAAM also. And this time we shall stay in the eastern edge, and she's talking about Philistine Ashkelon ancient genomes, revealing whatever it reveals. You will tell us. Thank you.
So thank you, and today I want to talk about our genetic analysis on people that lived in ancient Ashkelon. This project was a collaboration between the MHAAM team and the archaeological team that excavated Ashkelon. I myself am a geneticist, but I will try to also touch the archaeological context as best I can. So as many of you might know, the transition between the Bronze and the Iron Age in the Eastern Mediterranean was quite a dramatic time. So following a period of prosperity during the 13th century, towards the 12th century, the historical and the archaeological records show evidence of destruction in almost all of the major cities. Writing systems are being lost, trade routes are being cut off, and major players of the period, like the Hittites in Anatolia and the Mycenaeans in Greece, collapse. And yes, Robert Drews described it as a more catastrophic event of the fall of the Western Roman Empire. And one of the culprits that were suggested for these events is the so-called Sea Peoples, a group that is thought to have attacked and settled some parts of the Eastern Mediterranean. The best written evidence that we have about the Sea Peoples come from Egypt, from a mortuary temple of King Ramses III. There are several wall reliefs in this temple that depict battle between Ramses III and the Sea People. And one of the panels mentions the Sea Peoples and describes them as a mixed group. And one of the groups is called the Peleset. And already in the 19th century, there was a linguistic connection made between the Peleset and the Philistines that are mentioned in the Hebrew Bible. In the Hebrew Bible, the Philistines are mentioned as the arch enemies of the Israelites. And we also have some Assyrian and some Egyptian texts mentioning the Philistines, but we should remember that, of course, there is a bias in this historical account, since the Philistines themselves didn't leave any text, and we actually don't know how they identify themselves, if they saw themselves as one group, or maybe they identify themselves by the city they lived in, or by their religion, or anything else. So the Hebrew Bible mentions the Philistine Pentapolis, so the 5 core cities of the Philistines, and biblical archaeologists later on identified these cities to be in what is present-day Israel and the Gaza Strip. And actually, most of these cities have been archaeologically excavated. And when the archaeologists excavated these cities, they saw an interesting phenomenon, and that in the 12th century, these sites become distinct from neighboring sites in the material culture, in the architecture, and the pottery starts resembling pottery that is found in Bronze Age Crete. So out of this grew an hypothesis that actually these new cultural features were brought in by migrants from Crete. Other people argued there was actually no substantial movement of people, and there was maybe a diffusion of knowledge, maybe facilitated by trade, and this is what caused this turnover. There were also alternative sources suggested, like southern Anatolia or Cyprus. So genetics is a good tool to test these kinds of hypotheses, and we were lucky enough to collaborate with the Leon Levy expedition to Ashkelon and to screen human remains from the site of Ashkelon to address these questions. We screened more than 100 skeletal elements from Ashkelon, and as might be expected from the unfavorable environmental conditions in the southern Levant for the preservation of ancient DNA, we only had 10 individuals with enough DNA preservation to continue with analysis. We enriched them for over 1 million genome-wide markers. And yes, 3 of the individuals were from a Bronze Age necropolis that was used from the Middle to the Late Bronze Age. 4 individuals were from the early Iron Age, and 3 individuals were from a large later Iron Age cemetery that was adjacent to the city walls of Ashkelon. So the early Iron Age and the later Iron Age individuals are all identified by archaeologists to be of Philistine context. Interestingly, all the early Iron Age individuals were actually infants that were buried underneath early Iron Age houses. They all came from different houses, from 2 different phases, and we also found that they are genetically unrelated to each other. So again, you already are experts with PCA. So this is, again, a West Eurasian PCA calculated for modern individuals that you see here in the gray dots. The colored symbols represent ancient individuals. You might notice that early Holocene populations from Levant, from Iran, and from Europe form quite distinct clusters. And with time, there is a process of homogenization. And if we look at the 3 Bronze Age individuals here in the kind of turquoise circles, they fall in the so-called Near Eastern cline, close to previously published Bronze Age individuals from Jordan and from Lebanon, here in this green circles. When we then look at the early Iron Age individuals, we see that they're more heterogeneous than the Bronze Age ones, and they actually spread from where the Bronze Age ones position towards Europe and cluster, and the most extreme one clusters with where Aegean published Bronze Age individuals cluster. Surprisingly, the later Iron Age individuals are closer to the Bronze Age individuals than to the Iron Age, even though they're more far away temporarily. So we can already think of a scenario in which there was some European gene flow coming in Ashkelon during either the end of the Bronze Age or the early Iron Age, and then was diluted within the local Levantine population. So we wanted to test this scenario, and we used formal statistics based on allele sharing. And here we tried to see if any of the ancient or modern global populations that we know share extra affinity with the Iron Age early Iron Age individuals compared with the Bronze Age ones. And indeed, here in the warm colors, you can see that the Iron Age individuals share higher genetic affinity with populations all over Europe compared to the Bronze Age ones. We then went on to model all of the Ashkelon individuals in a 3-way model with the Levant and Iranian Chalcolithic populations. And as a proxy for European population, we used European Mesolithic hunter-gatherers. And what we see here is only that the early Iron Age individuals require this European ancestry to be modeled. But of course, the European Mesolithic hunter-gatherers are not the true source. They are around 10,000 years earlier, so we wanted to get a bit closer and to have a better estimation for the source of this gene flow. And for this, we compiled a list of possible candidates in terms of geography and in terms of time. And we did we tested over 50 models of 2-way and 3-way admixtures using the Bronze Age population and the candidate populations. And what we see is the only models that work are actually 2-way models of the Bronze Age population and Southern European populations. Of course, we need to remember that this list is far from being complete because many of the places around the Eastern Mediterranean remain to be sampled, and we also have some time gaps there. So to summarize, we detect gene flow from Europe coming into Ashkelon either in the late Bronze Age or the beginning of the Iron Age. And this coincides with the estimate of the Philistines' arrival there, or with the time of the appearance of the Philistine material culture there. We cannot detect this gene flow anymore in the later Iron Age. So within 200 years, basically it gets diluted within the local Levantine gene pool. And our modeling suggests Southern Europe as the most plausible source for this gene flow, but of course future sampling around the Eastern Mediterranean and the Southern Levant itself might elucidate more the precise source population for this. And I would like to thank everyone involved, and thank you for listening.
Thank you very much also for keeping the time. So we have now possibility for 1 or 2 questions before the break. David?
I saw that Sardinia was one of the possible sources.
Yes.
But then at the very end you said we need to test Sardinia more. Could you elaborate on that?
Well, when this analysis was done, I think only had we actually used modern Sardinians as a proxy, and there was no Sardinian ancient population published. I think now there's more data coming up that might help our resolution, but in general, I think sampling all over Southern Europe will help address this. Yeah.
Yes, please. Up there.
Hi, thanks for a really interesting presentation. So you seem to favor dilution as kind of that's your preferred scenario. Is that really preferable to just simple replacement by a population sort of basically identical to the pre-early Iron Age population? And if you were to sort of create a model in which early Iron Age was sort of forced to be an ancestral source for later Iron Age, like what would the percentage of contribution actually be?
Yeah,
I assume
so
a minority, but...
We did some modeling to test that, and and I think the maximum was around 10% of the contribution of the early Iron Age to the later Iron Age population. But we couldn't exclude that there was actually no contribution. So it is very well possible that another population, maybe not so far away, just replaced the people of Ashkelon at that time. But we can tell that the gene pool was quite similar. So it still was a Levantine population that came in if that was the case.
Well, thank you very much to you, Michal, and to all the 3 speakers.